Good evening. I'd like to begin with a few news notes. And first of all, Voyager 2, still on its way to Neptune, still working well, and sending back fascinating pictures. Just look at this. That is Neptune, and that large dark patch in the middle is just about the same size as the great red spot on Jupiter. And quite clearly, Neptune is a very much more active planet than Uranus. And then there are the Neptunian satellites. We've known of two. One of them, Triton, is large and goes around Neptune in a wrong way or retrograde direction. And the other one, Nereid, is small and has a very strange orbit, much more like that of a comet than a satellite. Now, Voyager 2 has revealed yet another satellite, about 200 kilometers across, closer in than Triton. And the most peculiar thing about this satellite is that it's not peculiar. It appears to be perfectly orthodox in size and in orbit. And we didn't expect that. And I think we may have to revise plenty of our ideas about the past history of the Neptunian system. Then you may like to see a picture the Russians have just released of the satellite of Mars, Phobos, above Mars itself. And this was taken, actually last February, and it's been released, by the rather ill-fated probe, Phobos 2, which of course went out of contact shortly after that. You know, it's just over 20 years now since men landed on the moon, and this has been remembered in many ways. Not least of all by the stamp collectors. And just look at these. These are sets of stamps based entirely upon NASA pictures. I am no stamp collector myself, and I'm quite sure these are going to be a collector's item in the future, and certainly that was a great moment. Many people, I'm sure, will remember that moment when Armstrong stepped out onto the lunar surface. Another interesting phenomenon that happened quite recently was an occultation of a star by the main satellite of Saturn, Titan. Titan passed in front of the star 28 Sagittarii and briefly hid it. And this lovely sequence was taken by the Salford Astronomical Society. I actually observed that from my observatory down at Chelsea, and I'm very glad I did, because it's very rare indeed, and it won't happen again in my lifetime. And just a note here for more serious planetary observers, apparently the south equatorial belt of Jupiter has virtually disappeared. At the moment, Jupiter is a morning object in Gemini. I've not been able to observe it for the past fortnight or so because of prevailing haze from my observatory down at Chelsea. But if you can look at Jupiter through an adequate telescope, do. Very interesting things are happening there. And now, on to our main theme. On the early morning of August the 17th, there's going to be a total eclipse of the moon, and most of it's going to be quite well seen from Britain, skies permitting. The Earth goes round the sun, the moon goes round the Earth, and so there must be times when the three bodies move into a direct line with the Earth in the mid-position. When that happens, all direct sunlight is cut off from the lunar surface, and the moon turns a dim, very often coppery color until it comes out of the shadow again. And even when the eclipse is not total, it is quite spectacular. There's a picture of near totality, and you can see what I mean. But of course, things are not always quite so simple as they might appear. And for one thing, the sun is not a point of light, it appears as a disk. The Earth casts a shadow in space, and that shadow is known as the umbra. But because the sun's a disk, to either side of the cone of umbra, there is an area of partial shadow, or penumbra, and of course, the moon must pass through the penumbra before going into the umbra itself. Also, note here that the shadow of the Earth on the moon is curved, and that was one of the very first proofs that the Earth's surface is itself curved, and therefore the Earth is not a flat plane as people used to think. The cone of shadow is long, and we've got a model here to show what's meant. We're representing the Earth by a table tennis ball, imagining that the sunlight's coming from the left, and we've made the cone of shadow here light, not dark, to make it clear to see. And there you can see the moon represented by a marble. And as you can see, the cone of shadow is very long indeed. The moon is rather less than 250,000 miles away from Earth on average, and the cone of shadow is over 800,000 miles long. And even at the distance of the moon, the diameter of the cone of shadow is well over 5,000 miles. Therefore, there's plenty of room for the moon to get inside it, and totality can, on some occasions, last for up to an hour and 3/4. But one thing you may ask, if the moon depends entirely upon sunlight, and all sunlight is cut off, then why doesn't the moon vanish? Well, generally it doesn't, simply because the Earth is surrounded by a layer of atmosphere. Here we see the moon again, inside the umbra, but round the Earth there is a layer of air, and that acts as a kind of a lens and bends some of the sun's rays onto the moon. And therefore, generally, the moon doesn't vanish, although, of course, everything does depend upon the state of the Earth's atmosphere, and some eclipses are very much brighter than others. Note also that when an eclipse of the moon is seen, it can be seen from anywhere on the Earth where the moon is above the horizon, unlike an eclipse of the sun where you have to be just the right place at the right time. And that's why any one particular place on Earth sees more lunar eclipses than solar ones. The moon, remember, has no atmosphere, and the lunar rocks are very bad at retaining heat. And as the Earth's shadow sweeps across, there's a very abrupt drop in temperature. It can go from something like plus 160 degrees down to minus 110 degrees very, very abruptly indeed. Although there are one or two areas which cool down less rapidly, and these are known, rather misleadingly I think, as hot spots. And one of these is the famous ray crater Tycho, there in the middle of the picture, 54 miles across with a nice central peak. And the fact that it cools down less rapidly than the surroundings is due entirely to its rather different surface texture. And then there's the strange case of Linnae, a white patch with a central craterlet on the dark Mare Serenitatis. You can see there to the upper right of that picture when I took myself some time ago. Well, it's been said that when Linnae is suddenly chilled by the Earth's shadow, the white deposit increases as though something is being deposited there. Well, I've often looked for this. I've never seen it. And on an airless world like the moon, you can't expect anything in the nature of frost. So, frankly, I don't believe it. All the same, it may just well be worthwhile having a look at the coming eclipse. And so now, let's go back to what's going to happen on the early morning of August the 17th, just after midnight. Now, the eclipse begins, the umbral eclipse, as to say, at 2:21 British Summer Time. Remember, that's 1 hour ahead of GMT. Totality begins at 3:20 Summer Time. Totality ends at 4:56, and the entire eclipse ends at 5:55, though by that time, of course, the sky is going to be impossibly light. But you'll be able to watch most of it, and you'll see the Earth's shadow sweeping across the moon. You'll come to totality, and then the shadow will decrease again until the eclipse finally ends. And at totality, well, who knows? It may be coppery, there may be lovely colors. We can't be sure. It depends entirely upon the state of the Earth's atmosphere at that time. Because remember, all light reaching the eclipsed moon has to go there by way of the Earth's air. If it's going to be spectacular to watch, even more spectacular to photograph. Now, I'm by no means a good photographer, and who better to tell us about it than Douglas Arnold? Welcome back, Douglas.
Okay.
First of all, what about film?
Well, essentially, as we've been seeing in your photographs, Patrick, it's a colour subject. And there are two types of film which we can use, all of us can use, negative, positive, and transparency, or positive film. They're both excellent now. The manufacturers have done a marvellous job for us, both as regards quality and speed. It's a question of advantages and disadvantages. A transparency film is very unforgiving of over or underexposure, but on the other hand, the subject, the image is there in the film when it's processed and comes out of the developing tank. Negative positive film is much more forgiving of overexposure particularly, but there, whether it's a machine or whether it's a printer in the darkroom, he doesn't know what that original subject was, particularly if it was a rather nice coppery moon, so you have a problem on that score. It's really a question of personal choice. The vital thing here with the eclipse is exposure.
Yes.
Now, as you were saying, Patrick, things depend upon what the state of the Earth's atmosphere is. They obviously also depend upon local conditions. You were talking about Salzy, for example.
Yes.
So it's very, very variable. So the important thing is to make sure one brackets. If we establish a relatively a norm or a guidance exposure, which we'll be talking about in a moment, the essential thing is to make sure that one brackets either side, over and under exposure, whether it be an aperture, if it's a variable lens, or a shutter speed, if we're working with a fixed focus telescope, for example, to go at least one either side, and better still, I think, two either side, because with an event of this kind, I think it's rather silly to economize on film.
Yes, indeed.
Now, that's the thing there. Now, we have some guidance here in a table as regards exposures. Now, let's assume, therefore, 400 ISO film we're using, which is a nice average speed film. The moon has moved entirely into penumbra, and that basically is not much different from a full moon when it's normal. So it's a daylight exposure, which most photographers will recognize, 2/50th at f11. Now, the eclipse progresses, and we have a little nudge of umbra coming in on the left there, but there really isn't much difference, so it's basically the same sort of exposure. the eclipse progresses further, we have a half phase, and now we're beginning to alter the exposure because of the growing umbra. Here we've just gone down one stop, as you can see. The eclipse progresses further, we have much more umbra now, and we have a relatively thin crescent penumbra. Now this is interesting because if we expose for the penumbra, you will see there 125th at f8, we have a lot of umbra, and now we can expose for that. It's much slower now, of course, a quarter at f2.8, quarter of a second. We go on still further. Now the moon, having moved totally into the shadow, it's not really much different from that thin sliver or crescent, so it's about the same exposure, and then we go right into the middle of totality where we're 1 second at f2.8, and if, for example, you were using an f8 lens, a telephoto lens of some kind there, that will be as much as 8 seconds or perhaps even more, 10 seconds. And of course you can choose a faster film. We have now excellent ISO 1000 films, and there we have the appropriate exposures on the right column there. Now we can put this diagram into a photographic form from actual photographs which I took on the February the 20th eclipse this year from Egypt. That's about the limit whereby you have a penumbra crescent coming in, you have the penumbra, which is the orangey, predominantly orangey, large gibbous area of the moon here. Now that was exposed for the umbra. The penumbra is becoming overexposed, but it's bearable. Now at the same time here, as we saw in the diagram, you can expose for the penumbra, the crescent penumbra, and get a very nice picture. And then as the eclipse progresses through, you get more and more of the moon returning from the eclipse. Of course, and on we go again, and we're almost there at full. The last picture in this sequence is one which shows the problem if you try and expose for a little residue of umbra. You get gross overexposure in the penumbral area, and of course it makes an awful photograph.
It does indeed. Now, what about equipment in general?
Well, we can envisage a variety of equipment here. Let's take one end, Patrick, whereby you assume a very experienced photographer, an excellent telescope tracking at the lunar rate. And here's a photograph taken by our very good friend Akira Fuji in Japan, who was one of the most talented astrophotographers in the world, I think.
Yes, indeed.
He took here, he was using a 30 centimeter or 12-inch telescope. It was tracking at the lunar rate, of course, and what's more, he was using a relatively slow, high-resolution photograph, and you can see the exquisite result that one can get.
Yes, well, not many people can do that. What about the man with very much more basic equipment?
Well, let's assume his photographic equipment, Patrick, is relatively basic, but he does have access to a mount which, of course, handyman can make to use manually, or can even make an electric drive, a simple basic camera mount which is tracking at the stellar rate. Now, you can do quite a lot of things with relatively moderate equipment. Let's have a look at this picture as an example. Now, here we have standard lens, perhaps about 50 millimeter or thereabouts, a little bit more, and you have the totally eclipsed moon in the middle of a very nice and recognizable Taurus star field with the Pleiades at the top and Hyades at the bottom. Now the thing about this sort of picture is it can only be taken during totality because the moon would be grossly overexposed. But notice what's happening here. The camera's tracking at the stellar rate. You're exposing, say, 5, 10 seconds, maybe 15 seconds on a fairly fast film, and you get a very nice effect indeed. Now, there's another, with the same sort of stellar tracking platform, there's another sort of picture you can get, and we have one here. This is again by Akira Fuji. This, I think, is extremely sophisticated. The camera is tracking at the stellar rate. Now, since it's doing that, the moon is moving in its own orbit, which is different, of course, to the stellar rate as you see it from Earth. And you see it quite literally. You're multiple exposing here. Of course, you're taking a series of pictures on one piece of film. What's happening is that you are literally seeing the moon moving through the Earth's shadow and out again. We won't be able to do that on August the 17th, of course, as you said, because we're losing more or less most of the latter half of the eclipse in the brightness of coming day and also the descent of the moon to the horizon, Patrick. But I think this is a marvelously sophisticated example of what you can do with relatively simple equipment.
Now, what about really basic equipment? The man who's got more or less a hand camera and very little else.
Well, let's assume, Patrick, that he or she indeed has got a single lens reflex, which is a great help, of course, a good firm tripod. B setting for the long exposures of totality, and things like a shutter release cable, which helps, and of course the ability to override the mechanism which moves the film on. Now we can do a number of things with this. Now let's have a look at this as an example. You have a fixed camera, you're on an ordinary tripod, but to be able to do this sort of photograph you must be able to override that film movement and take multiple exposures on one piece of film. You go through a part of the exposure, start with the moon, which is coming out of the eclipse here, as you can see. Start off at bottom left, give about 5 minutes between each of the exposures and go on through a period of the eclipse. And what you will find is that, say, with a moderate telephoto lens of, say, 200 millimeter, on a 35 millimeter frame, you will be able to get about 12 or so exposures and make really quite a pleasant photograph. And then there's another type of picture with that setup which we can also get, and we have that here. This is cheating to a well, it's not really cheating.
Yes, it is.
Well, all right. You can, whether in the camera or in the darkroom, you can take a couple of pictures. Let's assume that you have only a moderate telephoto lens, which is not going to make a main feature of the eclipse moon. It's going to be relatively small, and even if you blow it up, it's possibly not going to be terribly good quality to do a big enlargement. You can do a double exposure in the camera, and this is one which I did back in 1982 when I was in Las Vegas outside Caesar's Palace. What I did here was to take quite a conventional picture of Caesar's statue, which was quite nice and brightly lit, but I then changed lenses, put a moderate telephoto on the front, which was the only longish lens I had, remembering where Caesar was, bang in the middle, positioned the moon very, very nicely up at top right. Now, of course, there's other pictures of this kind. Now, this is one which is unashamedly, this next one, is unashamedly in the darkroom. This was taken by our good friend Vic Urban of the Alice Springs Astronomical Society in Australia. Vic took a picture, a flash picture of himself with two colleagues working at his Newtonian, and in the darkroom dropped in an eclipse moon at top left. Now, the picture of the moon was not a super one, because there's a certain amount of image smear there, but when you combine the two things, it makes really quite a pleasant picture. And then there's another picture which we have here, which coming back again to the sorts of compositions where imagination comes into play here. If you've got quite a nice funfair with bright lights nearby, you don't have to do it at the time. You can do it subsequently with copying, drop an eclipse moon in on that in the appropriate position.
At least there is plenty to do and plenty to see. Douglas, thank you very much.
My pleasure, Patrick.
Well, if we do miss this one, there is another total lunar eclipse on the 9th of February, but there won't be such a good one, and of course we can't depend so much on the weather, so let's hope for clear skies on the early morning of August the 17th. By the time the next program comes out, I'll be over in America awaiting the Voyager 2 pass of Neptune, and we're going to do our main program about that on September the 10th. Which has given us time to get and analyse and interpret all the various observations. And I'm quite sure it's going to be very exciting indeed. But we do have one more programme before that, and that's on August the 20th. And for that one, we're going once again to the great observatories in Chile and having a look at the observatories of Cerro Tororo and Las Campanas. And so, until then, good night.